my name is Aidan Arabzadeh and this is the R2R Ladder DAC. The purpose of the R2R resistor ladder is to convert a digital input on a set number of bits to an analog output on which the different levels of voltage dialed are displayed. The R2R resistor ladder serves as a digital to analog converter, or DAC, which is needed for digital devices to approximate varying analog voltage levels so they can work with real-world signals. This circuit uses 9 10.2 kilo-ohm resistors, 7 5.1 kilo-ohm resistors, a single pole, single throw rocker dip switch bank, a 1 kilo-ohm bus SIP resistor network to ground the switches at rest, a 5mm red LED, and a few jumper wires. In this circuit there are 8 switches, which can either read high or low. This enables the ladder to define one of 256 quantization levels on Vout, depending on which bits are activated. Thevenin equivalent circuits and superposition principle are used to break the R2R ladder down into simple elements and to calculate values respectively. Thevenin states that if you have a circuit consisting of linear components such as resistors and voltage sources, it can be simplified down to a single supplied resistor. Superposition principle says that any linear circuit with more than one power source can be analyzed by summing the currents and the voltage from each individual source. Let's say you want to find the voltage value of a bit. Let's go with bit 5. To do that, we need to first simplify the circuit using Thevenin, then calculate the values with superposition. Above the least significant bit, bit 0, the two parallel 2Rs simplify to R. These two are simplified down to R. So we've shorted all voltage sources except for bit 5, and now we can simplify. We simplified these two, and now we have the exact same thing again. So these are 2Rs, they simplify to 2R, where all of this circuit here can all be simplified to just R right here. Now what we have is 5 volts here, and since there are 2 resistors of the same value, in the middle here this is going to be 2.5 volts. And now we can simplify even further. So this is going to go down to R, 2R here and 2R here. So in the middle, it's going to half this voltage again. So this is going to be 1.25, and then there's going to be an extra R. And then these two are going to simplify together to 2R and 2R here. And then that's going to cut the voltage again in half, which is going to be 0.600 volts. So let's test that out. We're going to turn off all the switches except for bit number 5. We pull out our DMM. Let's measure this. And there you go. As you can see, we're getting around 0.6, 0.7 volts. As we know, these resistor values are pretty accurate to twice, but they aren't exactly, so it won't be 100% accuracy. In general though, the problem with the R2R ladder is that the current is diminished at the end of the circuit. So a voltage follower using the LM741 OP Amp can be added to turn a high impedance on the input to a low impedance on the output. Though it sounds great, there's actually a problem. So the 741 is not a full rail-to-rail op amp, meaning some values cannot be exceeded or gone under with a 5 volt source. And it has a voltage swing of around 1.8 volts to 5.2 volts. I'll show the pinout diagram on screen. Non-inverting input is connected to power. Alright, so we see that the top end is 5.2 volts around. And then if we were to switch this out for ground, we will see that the actual minimum voltage is 1.86 volts or 1.87. So that's the problem, and that's why we are not using the 741 op amp in this circuit. Thank you so much for listening, and I hope you learned something about the R2R resistor ladder DAC.